To put it bluntly, this eutrophication represents a monumental waste of resources, not only of water, but especially of nutrients. To get to the point, the urban return flows, i.e. water and nutrients, that reach a dam should rather be made part of its catchment, not dumped here. In other words, water resources and then also food from waste nutrients could and should be sourced from inside a catchment, i.e. in-sourced. This is key to sustainable urban water management. This can be achieved by incorporating in future urban landscapes a simple design feature to be called an in-source cell, or cell for short. Essentially, it would retain water and solids therein, designed in relation to its settlement context. The envisaged cells would have those biogeochemical processes found in wastewater treatment plants, as well as utilizing treatment processes found in natural systems. The selection of features from these two systems would determine their size and position within a network of cells in a catchment. Two forms of cells that represent the two main inflows into cells, i.e. respectively storm and wastewater, would be biofilters and DWATs. Here is a typical cross-section of a biofilter to take runoff from most forms of paving. Note for now the plants and filter media, and that they also relate to natural unpaved ground. Here is a cross-section of the just below the ground level box of a DWATS setup. Note for now the settlement and anaerobic zones, and not shown but optional aerobic zone as typically found in wastewater treatment works. Associated with DWATS is typically a constructed wetland that would polish the outflow. In all of the works mentioned, the common element is some box or cell, except that in the case of envisaged upstream multi-cell cells, there is a possibility of augmented base flow and storage, the use of plants for treatment, e.g. of heavy metals, and the creation of usable biomass. With appropriate on-site polishing, the effluent can be used for urban agriculture. There are many related benefits, especially of potential net positive energy production here, all of which will make a multi-scalar in-source cell approach more than sustainable for urban water as well as for food production.